Hello everyone, welcome back to the channel uLearn Education Online.
Again, we are back with another concept, that is power supply. As we know that for an integrated circuit or for any discrete component circuit, in order to work properly or to be on, it needs a constant power source from the power supply. Okay, so now we are going to see what are the power supplies that are used. So here we are having three types of power supplies that are used in the operational amplifier or for an integrated circuit. So first one is the balanced power supply and the second one is an unbalanced power supply. So these two power supplies are obtained from the dual supply. Okay, means it takes two supplies, thereafter you are obtaining different power supplies. And the third one is with the use of single supply, how we are obtaining dual supply. Now the question is why we have to use the dual supply. So as we know that this op amp, that is for an IC, we are having 4 and 7 terminals or the supply voltages. Here the fourth one is the negative power supply and the seventh one is the positive power supply. Okay, so we are calling seventh pin as VCC and the fourth pin as VEE or minus VCC or minus VEE from the internal circuit of an op amp. So we are having two power supplies. So in the practical we may use a single supply. From that single supply we can obtain dual supply, or else if we are having two power supplies then we can use two different power supplies that are connected to this pin numbers. Okay, now from the dual supply, how we are obtaining the power supplies. So there are two supply connections in the op amp. One is the balanced power supply and the second one is an unbalanced power supply. Now we are going to see what is a balanced power supply. So here, as the name indicates, that the two supply voltages. Now what are the two supply voltages? One is the VCC and other one is a minus VEE. So the two supply voltages magnitude must be equal and their common terminal is kept grounded. So if you see the circuit, so this one is one power supply and the second one is another one power supply. So here we are having one positive voltage, so plus VCC, and the negative minus VE. Now here these are the two common terminals. These two common terminals should be kept grounded in order to obtain the balanced power supply. Okay, and the second one is unbalanced power supply. It is similar to balanced power supply, but the major difference is here the two supply voltages magnitudes are unequal. Means, for suppose if VCC is some 15 volts, then VE must be 12 volts. Okay, here the magnitudes are not equal. So in the unbalanced power supply, it is mainly applicable in different applications such as powerhouses, whereas for practical or for simple experiments that we are doing in lab, for that purpose we are using only the balanced power supply. So this is the major difference of balanced power supply and unbalanced power supply. And the next concept is from the single supply, how we are obtaining a dual supply. So from this, so what are the circuits that we are using in order to obtain the dual supply from the single supply? So now we are considering the first circuit. Here we are having a single supply. Okay, so from this single supply we have to connect one positive voltage to seventh pin of op amp and one negative voltage to the fourth pin of an op amp. So here with the use of this resistive model, or we can say that resistive divider model, we can obtain the dual supply. So okay, now we are going to see with the use of single supply how we are obtaining or how we are deriving a dual supply with use of some external components. So if you observe, the first circuit that we are using to obtain dual supply from the single supply is a resistive divider network. Okay, so a resistive divider network, with the help of a ground, it is used to convert the single supply to the dual supply. And here for the resistive divider network we are considering the equal resistors, that is R and R. With the use of potential divider network we can obtain the voltage at this node is, we know that from the voltage divider rule, the voltage at this node is, voltage drop across this resistor must be equal to V in total supply voltage V in into corresponding resistor R by total branch impedance, that is R plus R. So finally VCC is V in by 2 and the other terminal VE is minus V in by 2. So from this we can say that here the positive and the negative supply will having a magnitude equal to single supply voltages, that is half of a single supply voltages. Okay, and here the capacitors are used in order to decoupling of a power supply. So from practically this resistor value should not be more than 10 kilo ohms. Why? Because these resistors does not have a capacity to drive a large current from the single supply. Okay, so here the resistor values are should not be more than 10 kilo ohms. So here we are obtaining the half of a single supply voltage. For example, here this is, we can say that it is a balanced power supply. Why? Because here the VCC and VE are having a same magnitude. Okay, so in order to obtain the unbalanced power supply, now what is unbalanced power supply? Here the VCC and VE magnitude should not be equal. So if the voltages other than this half of a input voltage, for this circuit we are preferring a Xenon diodes. Okay, so here we are preferring a Xenon diodes. In this Xenon diodes, we can say that the VCC is nothing but the Xenon diode VZ1 cut-in voltage or breakdown voltage, and VE is a VZ2. So if we are considering VZ1 and VZ2 are same, then we can obtain the balanced power supply. Or else if we are considering a different ratings of Xenon diode voltages, then we are obtaining an unbalanced power supply. The third circuit that we are using is, in order to avoid the damages due to the reversible polarities connected to the integrated circuits, these diodes D1 and D2 are used for this resistor divider network. So here it is nothing but a potential divider network, we can say that. So this is the indication of the potential divider network. So this is the concept of power supply. Thank you.